Number 14, express f of x in the form f of x equals quantity x minus k times q of x plus r for the given value of k. And we've been given the function f of x equals 2x to the fifth minus x to the fourth plus 3x squared minus x plus 5. And we're told k equals 1. All right, so just like number 13, if you watched the last video, we're going to come back to this here at the very end of the problem. But first and foremost, recognized with number 14, something similar to number 14, our primary task is to perform synthetic division. And we're going to perform synthetic division with a positive 1. We're given k equals 1, and this tells us what to perform the synthetic division with. So we're going to use positive 1. All right, and now we know that we have to, before filling in our coefficients, before we actually start synthetic division, we've got to take a look again at our function and make sure that we are in descending order of powers from biggest to smallest, and that we're not missing any terms. If we're missing a term, we've got to fill it in with a plus 0x to the whatever we're missing. So let's see here. We go from our highest degree, looks like 5, so we go from 5 to 4 to 2, so we skipped over 1. We skipped over number 3, x to the third. And then from 2, we go to 1, and from 1, we go to 0, or the constant. All right, so let's go ahead and fill in our missing term here. So we have 2x to the fifth minus x to the fourth plus 0x cubed plus 3x squared minus x plus 5. All right, and now that we've done that, we can see we go from 5 to 4 to 3 to 2 to 1 to none, our constant. So we're ready to go. We're going to look at the coefficient of each term and bring that coefficient, including its sign, down so that we can perform our synthetic division. So looking at our x to the fifth here, the coefficient is positive 2, so that will come down. Looking at x to the fourth, we have a negative 1 as the coefficient, so we bring negative 1 down. X to the third, the term we filled in, the coefficient is 0. Looking at x squared here, the coefficient is positive 3, so let's bring it down. Here, x to the first, the coefficient is again negative 1. And lastly, our constant, positive 5, so let's bring that down. All right, so we're ready to go. And we know with synthetic division, no matter what this first number is, we always bring it down. So we'll bring down that positive 2 and start multiplying. 1 times positive 2 is positive 2. Let's add vertically. Negative 1 plus 2 is positive 1. 1 times 1 is 1. Adding vertically, 0 plus 1 is again 1. 1 times 1 is 1. Adding vertically, 3 plus 1 is 4. 1 times 4 is 4. Adding vertically, negative 1 plus 4, positive 3. And finally, positive 1 times positive 3 is 3. And adding vertically, we have 5 plus 3 is 8. And we know whatever the last number here is will be our remainder. So let's section that off. So here to the left, we've got our quotient, but we're missing our x terms, so we've got to fill them in. So just like we're used to doing, we're going to go back up to our original function here, and we're going to look to see what the highest degree was initially. We can see the highest degree was 5, and whatever the highest degree is, you will always subtract 1, and whatever that is will end up being the power of the first x term here in your quotient. So 5 minus 1 is 4, so 4 will be the exponent of our first term. So x to the fourth. These were all positive numbers, right? So let's go ahead and quickly fill in our pluses. All right, so from 4, x to the fourth, we go to x to the third. From x to the third, we go to x to the second. From x to the second, we go to x to the first, but we won't write the 1 as the power there. And then from x to the first, we go to our constant. All right, so let's go ahead and write this down here a little bit. It's kind of squeezed together here, so we'll give ourselves some room. We'll say 2x to the fourth plus x cubed. We're not going to write the coefficient 1 plus 1x squared, but again, we won't write the coefficient 1. plus 4x plus 3. All right, so this here is going to be our quotient. And the quotient that you find is the q of x portion that we're looking for. Remember, we're looking for three pieces. We're looking for this x minus k, we're looking for q of x, and we're looking for r. So the quotient here is going to be our q of x, and it's helpful that they label it q for quotient, so you kind of remember what it is that we're looking for. So we've got our quotient, we've got our q of x. Now let's find the plus r, the remainder. Well, we found earlier that our remainder is 8, so that's easy enough. That wasn't too much work. So we've got the plus r portion. And now lastly, we need to find what x minus k is. And the k from the x minus k is the k that they give us. So what we have to do is take this expression, this x minus k, and plug in the k value that we've been given and then evaluate, simplify. All right, so x minus, and what is k? Well, k was positive 1, so we'll plug that in and evaluate. We'll distribute that negative sign through, so we end up with x minus 1. And there we have our x minus k expression. So we've got all three things now that we need in order to give our final answer. So we're going to say f of x equals x minus k. Well, what is x minus k? We just found it to be quantity x minus 1 times q of x. Well, what's q of x? We just found that earlier using our synthetic division. That was 2x to the 4th plus x cubed plus x squared plus 4x plus 3. And then lastly, our plus r. Well, our plus r, or rather our r, is just a positive 8. So we'll say plus 8. And there we have our final answer for number 14. So again, let me go through and just label what each portion here is, what each piece is. So this was our x minus k. Here in the center, this was our quotient, our q of x. And then lastly here, this was our r. All right, so there we have it, number 14.